Hello guys, welcome to Bugs in Code. The problem that we are going to solve today is walls coloring problem. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe my channel Bugs in Code so that you never miss out an update. So let's get started. So here's the problem, and this problem is basically a sequel of walls coloring problem, which I have already explained you. I'm even going to provide the link in the description box, but it is not a prerequisite. So let's get started. Here's the problem statement, and it says that there is a row of n walls in Geeksland. The king of Geeksland ordered Alexa to color all the walls on the occasion of New Year. Alexa can color each wall with one of the K colors. So unlike the previous year, now Alexa has K colors instead of just 3 colors. The cost associated with coloring each wall with a particular color is represented by a 2D cost array of size n cross k. Okay. For example, cost 0 is the cost of coloring 0th wall with color 0, and cost 1 2 is the cost of coloring wall 1 with color 2, and so on. Okay. You have to find the minimum cost to color all the walls, and you cannot color two walls with same color, so no two adjacent wall is going to have the same color. And if it is not possible to color all the walls under the above condition, then return -1. So I'm even going to give you the condition where it's not possible. But first of all, I'm going to explain you the example which is given here. So let's see the example. It says that you're given 4 walls. Okay, so I'm going to have 4 walls, like wall 1, wall 2, wall 3, and wall 4. Okay, so these are my 4 walls, and let's name them like 1 2 3 and 4, and I have 3 colors, so n is equal to 4 and k equals to 3. And what I have to do is okay, so cost array is also given here, like 1 5 7 and color 0, color 1, color 2, 5 8 4 and 3 2, 5 8 4 3 2 9 and 1 2 4. Okay, so let me even write the names for the color, like it is a red color, and after that I have green color, and after that I have blue color. Okay, so I have to color 4 walls. So what I can do is I can color the first wall with a red color, so it will cost me 1. After that, what I can do is the second color I can color with the blue color, second wall. Okay, so this is going to cost me 4, and after that I am going to color the third wall with green color, so it is going to cost me 2, and after that I will color the last wall with color red, so now the cost will be +1. So the total cost by doing this will be 1 plus 4 plus 2 plus 1, so it will be 8. There are other ways as well, like I can do like red, green, blue, and red. I can even do red, red, green, blue. So there are various other ways, but out of all those ways, this way is going to be the optimal way. So this is all about the problem statement, and let me just now move to the solution part. Okay, so let me take the same example here. So as usual, DP problem, we are going to start from the recursion. Then we will write the memoization code. After that, we will move to the tabulation code, and after that, we will move to the optimization. Okay, so but before doing all these, before all these stuff, we have to first determine whether it is a dynamic programming problem or not. Like if it is a DP problem, then how it's a DP problem. So we are going to do that as well. So let me start with the same example. Like I have an example which says that you have to color 4 walls, n equals to 4. So instead of at that point, write example here, n equals to 4 and k equals to 3. I have 3 colors, and the cost array is something which is 1 5 7 5 8 4, and after that I have 3 2 9. After that I have 1 2 4. Now let me what I'm going to do is I'm going to select this and I'm going to make it smaller and I'm going to store it. I'm going to like store it here. Now what I'm going to do is I'm going to try out all the ways to color the walls. Like what I'm going to have is I'm going to have a pointer on the first wall. So I'll start from the first wall, and now my current index is 0, and I'm also going to have a previous which is going to show me the color of previous wall. So it will give me the color of previous wall, and I will write previous here. So initially my previous is 1, so it is actually like it is previous here, and it is current index, so it is the index of first wall. Okay, now what I can do is I have to color the first wall. So for the first wall I have three options to color. Like I can either color the first wall like first wall with red color. Now I can color the first wall with blue color, and I can color the first wall with like first wall is actually the zeroth wall at zero index, so I'm going to call it even zeroth wall. So I can color the zeroth wall with green color. Now what is this one says that we are done with the wall 0 and now we are at wall 1, and the previous wall I have colored with this red color. I hope you guys understanding what I'm trying to say. After that what I can do is, since my previous wall is colored with the red color and I have to color the first wall, so I cannot color the first wall with the red color. See what I'm saying? I'm saying that I cannot color this wall with red color if I have red color in the previous wall. Why? Because no two adjacent wall can have the same color. So if I have a red color on the previous wall, then I can either color it with blue or I can either color it with green. So I'm going to write here like 2, and I can either color with blue, I can either color with green. Now what I'm going to do is I'm going to color this wall, this since this is blue, so I can color it with either red or I can color it with either green. Okay, what about this? I can either color this wall with the I can either color this wall with the red color, so I will have something like this, and I can even color it with the blue color. These are the options. Now what I'm going to do is, since I have colored the wall 0, wall 1, and now I have to color the wall 2. So I can color the wall 2 with since it is blue color, so I can either color it with red, so 3 and red, and I can color it with green, so I'm going to have 3 green. Similarly here I can color it with either red or I can color it with like blue. Now what about this? I can either color it with like blue or I can color it with nothing but green, so green. For this I can color it with either the red color or with the blue color, so like 3 and blue. For this wall I can color it either with the like blue color or with the green color. And okay, so red blue, blue green, red blue, and red green. Okay, so for this I can either color it with red or I can color it with green, isn't it? Now I have colored 0, 1 and 2 wall, and I have to color the last wall, which is the third wall. So let's do it. This wall I can color it with either like blue, so I'm going to have 4 and blue, and here I'm going to have 4 and green. For this I'm either going to have 4 red, and 4 means I have to color fourth wall, which is not there, so this is our base case, and for this I can either color it with red or I can color it with blue. For this I can either do something like 4 and blue, and here I will have 4 and red. So this is what we are going to do for all these, and like for this one I will have 4 and blue, and I will have 4 and red. Now this is what we are going to do. This is something which is trying out all the possible ways. So these are the all possible ways, and out of all these ways I have to find the minimum. So out of all these ways which I have, whatever is my minimum cost, I'm just going to return that cost, because it is showing me all the possibility. Like this is one of the possibility, and this is one of the possibility. Like since you can even relate them with the combination that we have in the previous like example. So if I show here, then I have first combination, I have red, blue, green, and red. I have more possible combinations like red, green, blue, and red. So you can relate here as well. Like here you can see that the first combination that we have is like this combination. I have here uh, okay, so red, blue, red, or blue. So it is nothing but R, B, R, and B. Similarly, I have R, B, G, and B. So I have all the combinations possible, and now I'm going to take the minimum of those. So this is the recursive approach, and let me just now move to the coding part. So what I'm going to do is I'm now going to move to the coding part. So this is the problem on Geeks for Geeks. I'm even going to provide the link in the description box. So let's get started. What I'm going to have is I'm going to have a function solve, which is going to take index and previous, no doubt, as I have explained you in the board. So but apart from this, it is also going to have the cost array. Now what I'm going to do is I'm going to write my recursive function as solve. It is going to have the current index, it is also going to have the previous, and it is even going to have cost array. Now what I'm going to do is I'm going to write the base condition first of all. So if my current is double equal to cost dot length. So cost dot length is basically the total number of walls. So let me even, in order to make the code more clear, so I will make it n equal to cost dot length. So it is my number of walls, and k is something which is my cost of zero dot length, isn't it? Now what I'm going to do is I'm going to pass even n here, so that it becomes more clear to understand in total walls. So if my current index become equal to the total wall, like all the walls have colored, so I'm going to return 0 in that case. Now what I have to do is I have to since what I'm going to do now is I'm going to find the minimum possible of all the ways. Like I'm going to have my minimum as, so now what I will do is each time I have to find minimum, so I'm going to run a loop for all the colors. Like cost zero dot length is nothing but the color of zeroth one, like the total number of colors that I have. So it is basically the value k. Now what I'm going to do is I'm going to check if my previous is equal to 1. I will tell you why I'm checking this. So else if my previous should not be the color that I currently have. So what I'm doing here is I'm traversing all the colors, like from 0 to k. Like I have 0th color, first color, second color, and I'm checking out the condition for all the possibilities. Like you can see here, what I'm doing is I'm traversing all the colors. Here I have colors like these three colors. So I'm traversing all three colors, and out of them I'm going to check which color I can do in the second wall. Like what I'm actually checking is, since if my previous is equal to -1, then I have to consider all the colors. But if my previous is not equal to -1, then I'm going to I'm going to consider all colors except that previous color, and I'm going to minimize the answer. Like the solution to this problem is going to be the minimum of these both value, isn't it? Like if I have the minimum of these two values, and then I can simply just add the cost to this in my answer. So if if my previous is double equal to -1, then I'm going to consider all the colors, else I'm going to consider all other colors except my previous color. So because no two adjacent wall can have the same color, so let me just do it here. So here I'm going to consider all the colors, and I'm just going to minimize my cost. So it is going to be my minimum and solution to current plus one is going to be the next wall, and previous is now going to be my ith color, and I have cost and I have n. And in this I'm going to add the since this is nothing but this is coloring the current wall with the eye color, so I'm even going to add the color here, so the cost here, so it is going to be my current and eye. Okay, and what we are going to do here, we are going to write the same statement here, no doubt. So, and after that, what I'm going to do is I'm going to return my minimum. Let's see whether it works or not. So this is our approach, recursive approach. Let's see whether it works or not. It may show compilation error. So let's see. Okay, it's showing previous. There's something problem with previous. Here I have used previous, but instead of previous I have to pass -1, because initially the previous is -1. And let's check now. Okay, I is something which should also be removed from this point, and now let's see how it works. Okay, so it's working, but I want to tell you one more case that can be there. So that case is, let's consider I have to color, like I have to color all the walls. I have to color one wall, and okay, so I have to color 5 walls. Let's say I have 5 walls here, so like this and this and this and this. So I have 5 walls here, and I have to color all of them, but I have only one color. So can I do it like I can color this wall with the particular first color, and then I must have to do it with the same color, but it is not allowed. So in this case I'm going to return -1. So the code is something that is automatically going to handle all the cases, and what I need is I just need to check here that I'm going to store it here. So if I have only one color available, then it is not going to pass this condition, and my minimum will be the max value. Okay, so even make it max value by 2. I will tell you why I'm making this max value by 2. And now I'm going to check if my answer is something which is greater than equal to integer dot max value by 2, then I have to return -1, else return answer. I'm taking here integer dot max value by 2 because whenever I do integer dot max value, so let me write here why. So this is because whenever I do integer dot max value plus 1, then it becomes integer dot min value. So in this case and when we are doing +1 or plus something, so at this point if my minimum is integer dot max value, so whenever I do cost of current and I, then it becomes something which is very minimum value. So and it is going to take that minimum value again and again, so that's why I am doing by 2 here. So let me now submit this code and let's see. So obviously it is going to give me time limit exceed error because it's a recursive approach which is trying out all the ways. So I will even provide you, let's see. Okay, so it's giving me time limit exceed in the 8 test case. So let's see what we can do here. Okay, so if you see this recursive tree, then we can make one observation like, okay, let me take a different color. So if you see this subproblem and this subproblem, so what we find is we have repeating subproblems, like you can see, and we have already seen that how this problem is having an optimal substructure. So the first condition that if it has like uh, the first condition that it's following is optimal substructure, optimal substructure, where a problem, the solution to a particular problem is dependent on the problem subproblem. So but we see one more thing, that is overlapping subproblem here. So I will write overlapping subproblems are also there, subproblems are also there, like you can see here, and you can even see this three red and this three red and this three blue, this three blue, this three blue, and this three red is like which is matching to these. So we have so many repeating subproblems, and what we can do is we can apply the memoization technique, where instead of solving these again and again, what we do is we store the solution to this subproblem somewhere, and we just check whether we have already solved that or not. So let's see whether how we are going to achieve that. Now what I'm going to have is I'm going to have an array which is going to be my DP array. I will call it a DP array. Let me make it integer array, and now the size of this array is going to be n cross k. DP is going to be, why I'm saying n cross k, because you can see here that you can see here that we have one variable value which is current, which is changing from 0 to n, and we have another value which is changing from 0 to like color, 0 to k color. So I have to store the sub problem to this problem somewhere. So what I'm going to do now is I'm going to when I return this, I'm also going to store it. Okay, so but I cannot return this simply because I have to check my previous is -1 or not, because in that case it is going to give me time limit exceed. So TP, oh, I mean in that case it is going to give me array index out of bounds. So if my previous is not equal to -1, here I'm sure my previous will not be equal to -1, so I'm going to return my answer in value. And if my TP of I and previous is not equal to -1, null. Then what I can do is, if my previous DP of I and previous is not equal to null, then I can simply use the value at DP of I and previous. Else I have to call this function. I have to call this function here. And what I'm going to take is, I'm going to take the value here. So this is the dynamic programming memoization approach, and I'm going to write one more condition which is very important. So if my previous is not equal to -1 and DP of I and previous is not equal to null, then I'm going to return my, like if I already have the solution for the current subproblem, then I'm going to return that solution. So let's see whether it works or not. Okay, I have written -1 here, and here I have not equal to null. And okay, so it's giving me time limit exceed. Okay, why I am taking like I again and again? Let's make it current. Okay, so here I'm going to make it current again, and even here, like I'm going to make it current, and here I will have I. Similarly, here I will have I, and here I will have current. And now what else I can do? I'm going to make current here. Let's check now. Okay, oh okay, it's giving me a wrong answer. Let's see why it's giving wrong answer. So my DP of current and previous is not equal to 0. Okay, so what we are doing is here we are calling for current plus 1 and I. So make it current plus 1 and current plus 1. Let's see now. It's uh, it's saying that you are out of bound at line number 53. Line number 53 says that you're out of bounds, so I'm going to make it n plus 1. And now let's see, it's showing out of bound because this condition is not reached yet, and it is when it becomes n plus 1, current plus 1, then it reaches to n and it is out of bound. So it's working for the example test case, and let me just submit it and check whether it works or not. Okay, so it's working and it is going. Okay, let's see. Okay, so it's showing time limit exceed, but let's see why. uh, okay, so actually let me do the complexity analysis of this solution. So what we are doing is we are having a DP array. We are having a DP array of n and k, which means that we have total n cross k subproblem, which we are going to have n cross k subproblems. And for each problem, what we have is we are running a of k loop in order to find the minimum. So even you can see in the, like, you can see here in the code that what I'm doing is I'm having a 2D DP, and apart from this I'm also running a of k loop here in order to find the minimum. So that's how the complexity of this problem, this solution is going to be of n cross k cross k. So what I'm going to do is, since it is showing time limit exceed, so what I'm going to do is I'm going to reduce this complexity to something which is O of n cross k. And I hope that when I reduce the complexity to this extent, then it is going to be accepted. Let's see what we can do. The example that we have is we are going to see, take the same example. So the example that we have is n equals to 4 and k equals to 3. 3 colors, 4 walls, and we have cost array which is 157 and 584. After that we have 3 2 9. After that we have 1 2 4. So it is basically for all the walls here and all the color possibilities. Now what I'm going to do is I'm going to write the tabulation approach, and with the tabulation approach I'm also going to give you the intuition behind the most optimal approach. So let's see what we can do. What we are going to do is we are going to have an array which is of size n cross k. So I have 4 walls here, 1 2 3 4. I'm even going to name them uh, 1 2 3 and 4 walls, and I have 3 colors. So for here I have 3 colors. Okay, now for the first wall, see, for the first wall, the color of coloring the first wall with the like, let's say the color is red, green and blue. So the cost of coloring the first wall with the red color is same as the cost given here, so it is going to be 1. And after that the cost of coloring the first wall with a green color, so it is going to be 5 and it is going to be 7. Same for the first wall. Now for the second wall, what I'm going to do is I want to color, okay, so this cell represents what? Let me write first. So dp of I and j represents the cost of coloring jth wall. So let me write here cost of coloring jth. Okay, even let me take some other pen. It is not visible, so it is basically going to be cost of coloring jth wall with ith okay, with ith color like the current wall will have ith color. Let's see. Here we can see that the first wall is nothing but this wall. So this wall is going to have the red color. So this means that we cannot consider this color because no two adjacent wall is going to be having the same color. So what we can do is we can either take this value for the current mm, color and either take this value, which means that if I color this wall with the red color, then I have to color the previous wall with either 5, either green color or blue color. So I'm going to take here 5 because 5 is minimum, and I'm even going to add the value 5 here because this is the cost of coloring the current wall. And what about this? This is the cost of coloring the current wall with green color. So here I'm going to take minimum of 1 and 7. So minimum of 1 and 7 is 1, and here I have 10. So 1 plus 8 I'm going to take. And similarly for this I'm going to take 1 plus 4. Now what about this third wall? This third wall says that if you are coloring the current wall with red color, so don't consider the red color for previous wall. Instead consider green and blue. So what I'm going to do is I'm going to consider 1 plus 8, which is 9, and here we have 1 plus 4, 5. So I'm going to consider this 5. So 5 plus 3 here, and after that I have 5 plus 2 here, and I have, okay, so it's 5, and what I'm going to do is I'm going to take this 9 now, and 9 plus 9 here. After that here, so it is basically 8, and it is 7, and it is this is 18. Now for this wall, what I'm going to do is I'm going to color it with red color, and I'm going to consider previous for the like green color. So I'm going to have here 7 plus 1, and which is 8, and I'm going to have here which is 8 plus 2, this is 10, and similarly I'm going to have here, I'm going to have nothing but this 8 plus this 4, so it is going to be 12. Now okay, so I'm going to take this 7 plus 4, this is going to be 11. Now I have my DP array. So out of when I have colored all the walls, like I have colored the last wall, then I'm going to take the minimum cost. So this is basically the cost of coloring 4 walls with all the colors. So I'm going to check which is the minimum cost. So here 8 is the minimum, and 8 is going to be my output. But I want you to notice one thing here, that here okay, so at this point which value we considered is something which matters a lot. Like at this point, since I have 1 here and 1 is the minimum cost, so for all these walls I'm going to consider 1 because 1 is the minimum cost. So why to find this minimum again and again? So what we are doing in the previous approach is we are going to run O of k loop in order to find the minimum wall again and again. But instead what we can do is we can keep track of minimum, and once we have minimum, so we are using the same minimum again and again, except for one case where we have the same index. Like for this wall we have the minimum for the same color. So what we are going to do is we are going to keep track of one variable, which is so for this particular case we are going to consider second minimum, which is 5, nothing else. Now for this wall what we have is we have our minimum as 9, and we are okay, so we have minimum as 5, and we are considering, you can see 5 everywhere, except for this case we are considering the second minimum, which is 9. Similarly for this we are considering our minimum like 7 everywhere, 7 plus 4 we have here, and except for this case we considered 8, which is our second minimum. So let me just do it quickly again in order to show you how we are making the use of minimum and second minimum. So I'm going to draw my DP array again. Okay, so I have this DP array, and initially for the first wall I have 1, 5 and 7. So my minimum is 1 and my second minimum is 5. What I'm going to do for the next wall is, let me, okay, so I'm going to write this 157 584 329 and 124 again. So let me write here 1. I have something which is 157 and 584 329 and I have 124. So these are the costs. Now this wall, what I'm going to do is I have to color it with red. So I'm going to consider the minimum for the previous, which is 1, but the problem is 1 is at the same index, so I'm going to consider the second minimum, which is 5. So my cost will 5 plus 5, which is 10. Okay, now for this one I'm going to consider minimum, which is my 1 and plus 8. So 1 plus 8 is going to be 9, and here we are going to consider minimum, so 1 plus 4 is going to 5, so it is 1 plus 4. Now my minimum second minimum will change. Now my minimum will become 5 and my second minimum will become 9. I hope you guys are getting the intuition. We are at this point. So what we are going to do is, since our minimum is 5 and 5 is not at the same color, 5 is not for the same color, so I'm going to consider right 5 plus 8, which is 5 plus 3, which is 8. For this I'm going to do 5 plus 2, which is 7, and for this we have the minimum at this index, so we are going to consider the second minimum. So 9 plus 9 is going to be 18. For the last wall, what we are going to do, we are going to, first of all, these are going to change. So minimum will now become 7 and second minimum will become 8. So let's see for the last. Here I have the cost 1. So I'm going to do 1 plus minimum, which is 1 plus 7, which is 8. For this, I have the minimum at this particular index. So I'm going to consider the second minimum, which is going to be 2. So 2 plus 8 is 10. For the last wall, I have the cost as 4 and I have to consider this minimum. So this minimum is going to give me 7 plus 4, which is 11. I hope you guys got the intuition how we are going to make use of minimum and second minimum in order to solve this problem. So this is all about this problem. At last, we are just going to, okay, so when our iteration completes, then I will have from here my minimum as 8 and my second minimum as 10. And I just need to return the minimum from here. So I'm done with the explanation. So let me just now move to the coding section. And so first of all, what I'm going to do is I'm going to reset the code. Now I'm going to have my DP array as, first of all, I'm going to have something which is my n and k value. So my n is going to be cost dot length and my k is going to be my cost 0 dot length. Now what I'm going to do is I'm going to have my DP array, which is having k and n size. After that, I'm going to take my minimum and second minimum. So it is initially will be integer dot max value and second minimum will be integer dot max value. After that, okay, so I have taken row as n and column as row as k and column as n because it is going to give me the same structure that I have explained you like in the board. So what I'm going to do is now I'm going to run a loop for the first wall. So for the first wall, I'm going to have a loop for all the colors and I'm just going to fill my DP of 0. So DP of I and 0 is going to give me cost of 0 and I. After that, my, okay, I will check the condition for my minimum second minimum. Like if my current cost, right, 0, if my current cost is smaller than minimum, then my second minimum will become my minimum. I hope you guys know how to find the minimum and second minimum in an array, and if you don't know, then you are going to know by doing this, by solving this problem. So I have 0 and I have I here. Now else if my cost of 0 and I is just smaller than the current one, like the second minimum, so my second minimum is something which is going to change and it will become cost of 0 and I. Now this is for the first row. Okay, and now I'm going to do for the second row, but for the second row I'm going to have two variables, which is the current minimum, and I will have a current second minimum. So I will have current second minimum. Now I'm going to run a loop from I equals to 1. So I'm going to color all the walls now. Just see how I'm going to achieve it, and I will try out all the colors. So my J is going to be 0, and now my J is going to be 0 and J will be smaller than K and J plus plus. What I'm going to do is I'm going to check if my DP of like J and I minus 1 is double equal to minimum, then I will consider second minimum. So my DP of J and I minus 1 will be equal to cost of, so it will be equal to cost of I and J plus second minimum, and else DP of J and I is going to be, okay, so here my DP of, actually I have to write DP of J and I. DP of J and I is going to be cost of I and J, the cost of I and J plus minimum. Now I'm going to calculate my second minimum and minimum for the current row as well. So if my DP of J and I is smaller than current minimum, then my current minimum is going to be, my current second minimum first of all is going to be current minimum, and after that my current minimum will change and it will become DP of J and I. Else if my DP of else if my DP of J and I is just smaller than the current second minimum, then my current second minimum is going to change and it will become DP of J and I. Now what I'm going to do is I'm going to update the value of my current minimum and current second minimum. So my minimum is going to be current minimum, and my current second minimum, like second minimum is going to be current second minimum. Okay, now at last I just have to return at last I just have to return the minimum. So I'm going to return one thing that I have to do here again and again. I have to initialize my current minimum, current second minimum, and current second minimum is going to be my entry short max value. And now what I'm going to do is I'm going to check if my minimum is if my minimum is double equal to integer dot max value. So this is the case where we don't have any possibility to color all the walls with K colors. So let's just return it, submit it. Let's see whether it works or not. So okay, it's working. For the first wall we have this, and for the rest of walls we have this code. And let me just now submit it. I hope it should work. Let's see. Okay, so it's showing the wrong answer for this. What I need to do is I need to check if it is equal to, okay. So let's see now whether it works or not. I'm just submitting it. I hope it should work. Okay, so it's working for all the test cases, and let's see. Okay, so it's working. This is all about this problem. I hope you guys like the solution and the way I explained. So this is all about this is all for now. Thank you.